Hello, my name is Alan Pickering, and this is my latest hot air engine that I built during the lockdown period of the virus epidemic in 2020. I built many hot air engines, fairly large. They're all freelance and they're all available to view on YouTube. This is my first attempt at running this thing, and it seems to be very good. It's a water-cooled Robinson layout of my own design, and it heats up very quickly. Now, while I'm talking, I might as well switch it on, if I can do it one-handed, and you can see it running. There we go. Lovely. It's on a magnets underneath, and that stops it sliding around. There we go. It's a totally silent machine, absolutely 100% silent. Only the burner you can hear go. So that's been going a few seconds, and the chances are it'll work. There she goes, it's even trying. Just thinking about it. And away she's going. Oh no, she's that. This is a little flap I made. Presumably, whether it can be read in that, I don't know. There we go. I'll just leave it to warm up a little bit. Turn the gas up, if I can. It's on full gas. It's on full gas. So it's doing quite nicely, thank you very much. Okay, I'll turn this off now. You'll find it will keep running forever on no gas. I can turn it the right way. Yeah. I'm very good at this. There we go. Get it down to a small level. Right, this is the water cooling tower. There she goes. Now, after about 2 hours running, you can just about bare your fingers inside. That's cold now because it's stone cold. And this is the water jacket that does the cooling. And this is a little air bleed valve, just to stop you getting any air pockets in the thing. Water should come out of this in theory. I can turn it on. Oh, there we go. There she is, making a mess everywhere, So, what we do is just give it a quickie squirt of air. There we go. An essential tool for any workshop, compressed air. That's the secret of a tidy workshop. Come on, get in there. There we go, turn it up again. Alright, this pipe here was a bit of an afterthought, and it's basically, to encourage thermic activity. The water at the bottom is always cold, hot water rises, and it'd be nice if there was a bit of thermal activity going through there and in a big circle, and keeping the bottom warm. Now, in about 2 hours this gets to blood heat. So I should think this will run forever, really. There's no problem of it running for a long period. I've only had it going for about 2 hours. Now that's a very low setting there on gas. And we'd like to see that keep going like that. Now the beauty of this Robinson linkage is this. There is your displacer piston going up and down. And it's going up and down dead vertically. In fact, it's only about 20 or 30 thou away from the vertical. And this is very nice because it means you can have a small 3/16 shaft with no gland in there. If it was a big shaft, you'd need a big gland and you'd get air leaks. This has got no gland on it. It's going up and down, so it's not going sideways and wearing. And the weight of the displacer piston is assisted by gravity, so that's a good thing. There's your power piston, and that is a 34mm piston. I think it came out of an outboard engine or a chainsaw or something. This crank web here is off a Seagull outboard motor. The last engine I built was a Ross yoke engine, and I sawed the crankshaft in half, and this is the other half. If I stop the engine, you can just see it. There it is. And I rescued it, and I made 2 hot air engines out of that web. There it is. There it goes round again. Now I've got bearings in everything that moves. And there. This one I put a bearing in, but it was a waste of space really because it never turns round. Still it matches the other one. Have a little walk around the engine. This proved to me to be a very difficult engine to build. It was a shocker. There are 50 2BA screws in the thing, and when I put a 2BA screw into a pipe like this, I like to use just the first taper tap and just push it in about halfway to 3/4, and you get a sort of a taper thread, and you can force each 2BA screw in tight so nothing moves. And the clearance drill I also make tight, so the whole thing goes together as though it's been put on dowels. This is a 5/8 crankshaft of silver steel. This here is a flame guard. It's guarding that flame. In other words, it's stopping the flame licking around the sides and warming up this water chamber here and spoiling the paintwork and all the rest of it. This copper pipe here is the transfer pipe. It goes from the cold end of the displacer and straight up into the power piston. Now then, it goes in here, and the first inch of this stainless steel cylinder is solid, and so this is quarter VSP going into a solid stainless steel piece there, which is also tapped, and that's the bolt that holds it together, and that's the nut that makes sure it's in the right place. This is still leaking. Now the reason I've done that is because a failure of many hot air engines is oil getting into the hot end of the cylinder by the burner. It always finds the hottest place, and if it can get there, it always does. So in this case, because the cylinder is higher than the displacer, I made sure that the input of this pipe goes in on the centre line, so that any oil in there by gravity won't go down, because it goes in up and through on a centre line like that. That's a downfall of many engines, and all my engines I make sure that oil can never get into the top end of the cylinder. Let me just walk around a little bit. Now, it's still ticking away, very slow rate. The clearances are very fine, and this was all put together. Well, it was drawn out, not drawn out, but it was marked out using an optical centre punch and a watchmaker's eyeglass. It was very tricky to set up because these big 4-inch columns then built to hold skyscrapers up, not precision hot air engines, and so consequently they're not square, and so there's an awful lot of squaring up to do with them, and this piece here is quite a difficult piece to make. I call it a water spacer, and it's full of holes and a great big load of milling inside, and it's that is difficult to make and set up and get square. These engines, they are very, very touchy. They're not like steam engines. A steam engine will always work, no matter how badly made. But a hot air engine, never. They've got to be precision made. And the ones that are noisy are because they've got the alignment wrong and the bearings are all over the place and making a noise. They like good workmanship, and the slightest bit of out of alignment and they stop dead. They won't work. They have got to be made properly, and it's not an easy engine to make, and it looks a dead easy engine, but I've made a lot of models, and this is as difficult as they come. Not because of the work involved, because, you know, a traction engine or a steam lorry, there's a lot of work involved. But this is more precise and more precisionally made than any of my other models. And I've been making them for 50 years. This was particularly pleasing because all hot air engines that I've ever made, I've made about 6 or 7, something like that, they don't work when you finish them. And then the water leak and all sorts of things, and there's air coming out of where it shouldn't do, and unless they're 100% they won't work. And this one, I just wafted a flame over it and round it went. I haven't touched it. I built it, and before I painted it I wafted a propane burner underneath, and round it went to my amazement. And it's never stopped running. This is about the 3rd time I've run it. Let me just turn the gas up a little bit. I'll turn it down a bit. Let's see how slowly it goes without too much. See, there's no gas there at all. Very little. And there's certainly no noise. Now this cylinder is a piece of bright mild steel tube, 3.5 inches in diameter, thinned down at the burner end and thick at the inside the casing here. Because stainless steel is not very good at transferring heat. And I've always used sugar basins in the past, and this one I've used a sugar basin on the actual piston, but the cylinder is ordinary bright mild steel. Having said that about sugar basins, this flame guard here is in fact the lid of a stainless steel sugar basin, and I've put this piece of steel around it. Oh no, it stopped on me. Go on a bit. Go on, up you go. There we go, get a little bit more. Go on you. But the silence of it is the thing that really turns me on. Hopefully this will be published in Engineering in Miniature or Model Engineer. All my other stuff has gone in Model Engineer in the past, other than any front covers. I'll show them in a little minute. I'll just move around the workshop and show you one or two hot air engines that I've made in the last 4 years. There we go. Sorry for the juddering, but I'm not very good with cameras. There's my Lays, my Big Mitchell, and Smart and Brown. No lights on, unfortunately. These are a few of the front covers I've had over the years. Those are my two last hot air engines. That's the very last hot air engine. One of my traction engines. A Crucible, and my big Ransom's crawler that I converted to steam with a boiler and a new engine. That's my workshop articles. And that's the latest, well not the latest, an old Foden tractor freelance that I've made in the past. Just going back now and see if my engine's still running. These are just general workshop pictures. It's a very useful thing. Should be made compulsory. Bench lineager, twist drill grinder, dormer, workbench with all the materials underneath, staging block, press, coordinate drill, Swiss. Couple of compressors from Aldi, very good they are too, 5 horsepower, 2.5 each. Another old drill, built the Titanic. Walking back through, tapping machine, bandsaw, plough surface grinder, welding, parts washing, another horizontal bandsaw, little silver soldering setup over there. A big, heavy, Smart and Brown, Brown and Sharp. There it is, Brown and Sharp, omni-mill, horizontal and vertical. These are the big lumps that you can, and mills and things you can put on it. This is a very useful drill which I inherited, and I would have not, or been very difficult to make this hot air engine without it, because the table goes round, it goes up and down, and it twists from side to side, and this thing is such an awkward lump that you can't get it onto any drilling machine any sense. It's got to have a table that moves all over the place. This is a rotary table on a slotting machine, never used, white elephant now, but when I was building traction engines it did all the keyways and things. It was very handy. This is a useful tool, essential, a polishing machine, a wire brush. Never stop using it. And a secret for keeping a workshop nice and clean and tidy is a little Henry Hoover. Already plugged in, all you do is switch it on. That's an ultrasonic cleaner. Cleans carburetors and nice bits and pieces. So that's a general view of the workshop. But I've been doing it for 50 odd years and I'm now 82, and it's time to, I think this is going to be the last one now. I really can't, I haven't got the stamina to keep these things going. In fact, I think it was only this coronavirus that kept me in, that's made me sort of build something else, which I said I'd never do. Let me turn this down a bit now, see what happens. Working wise, this is the nicest little engine I've ever built. Because it's so sweet and it's so quiet. But be warned, if you want to make one, it isn't easy to make, or not to make well. It's getting everything marked out absolutely perfectly. Within thous, this is the problem. Because there's so much welding, every time you weld, the metal moves. You've got to start again. I made many mistakes when I made this because I never wrote anything down on paper. And age was catching up with me. Stupid things. I'm absolutely fanatical about precision. When I measured the conrod, this is the conrod, I measured that exactly to a thou, spot on. Made it, took me ages to make. When I finished it, it was a bloody inch too long. I get the thous perfectly right, but can't count the inches. This top link here, got it absolutely spotless, lots of work on it. When I finished it, it was half an inch too long. But absolutely to the thou. Can't count the inches on the ruler. Anyway, let's line up a little bit. I like to see these engines going slowly. To get an engine going slowly is much harder than to make them go fast. That's why I like the Ross yoke engine I've just completed. It goes, a third the speed of this one, and absolutely perfectly balanced. I'll turn this down a little bit more. If I can. There's really no flame up there at all. we go any lower than that, it'll go out. And how sweet is that, just ticking away there? If you want to see my other engines running, have a look on YouTube. Tap in Alan Pickering History, Alan Pickering Workshop, Alan Pickering Hot Air Engine videos. You'll come up with something. So there we go. So I hope you enjoyed this little go here. I think I've covered just about everything. The flywheel is 9 inches. It came off eBay for £12. She's still going round. So there we go. That's Alan Pickering signing off. I hope you enjoyed this little video. Thank you for watching.